All right, so for the test review, guys, I'm going to work on the second page. I'm going to do the second page, the third page, then go back to the first. Your test tomorrow, you need a calculator. It's got to be a scientific calculator. Don't bring in a graphing calculator. But it's going to have a total of 15 questions. 15 questions. You're going to have 9 free response. We call them FRQs, free response questions. So you answer the question, show me work. And then you're going to have 6 multiple choice. Okay? So not quite half and half, but, close to that. So I'm going to go over all the different types of questions that you need to be familiar with. Make sure you guys are paying attention specifically to the ones that I'm doing today, okay? So let's look at something like numbers 1 and 2. Don't worry about 3 and 4. Let's look at something like numbers 1 and 2. The question is going to say, tell whether the function is exponential, growth, or decay. And then what does the next thing say? Explain your reasoning. It's not enough to just say growth or decay. You have to tell me why. Remember, this is your base, right? So the reasoning doesn't have to be a paragraph. I don't need you guys to say, well, the reason I thought this is because... No. Guys, is this a growth or a decay? This is a growth. Right? It's an exponential growth. You can tell me that just like this. You could say exponential growth. And your reasoning why? Because the B value is greater than 1. That's it. That's explaining your reasoning. That's you guys understanding. If you want to say the base is greater than 1, that's fine as well. But that value is greater than 1. That is explaining your reasoning. So identifying whether it's a growth or a decay, partial points. Telling me why is the other part. Does that make sense? Let's look at the next one. Is this an exponential growth or decay? Why? Not just less than 1. It's in between what? 0 and 1. All right, it's in between 0 and 1. If there was a negative, it's a good question. If there was a negative out in front, that doesn't change. This is still a decay. This negative just makes it a reflection. You guys are going to have that. Tomorrow, I just need you to tell me, it switches the way that the graph looks. Okay. If you wanted to write in words, because 3/8 is in between 0 and 1, that's fine. You don't have to use an inequality statement or anything like that. But just so you guys understand the reasoning. Comprende? All right, let's move on to this section down here. If it says to simplify, you're making smaller, right? The word evaluate means tell me what the answer is. So understand the workings of multiplication. Yes, we're using logs, but the multiplication properties of exponents still remains the same. If I look at number 5, I have e to the 8th times e to the 4th. Do you guys have the same base? Yes, so then what do you do to exponents when it's the same? So 8 plus 4. So you would simplify this to e to the what? Perfect. That's it. That's showing me all the work I need to see. Guys, I'm going to work up and down just so I'm not going back and forth like that. What do we know about number 8? I have e to the ln of 9. Why do they cancel? They are inverses of each other, so they cancel out. So your answer here is 9. There's no trick to that. I'm not trying to see. Guys, you're not going to put that in your calculator. Some of you would have absolutely no idea how to even begin to put that in your calculator. So just make sure that you understand those are inverses of each other. All right, let's look at the next one. What's going on here? Oh, do you need me? Okay, what's going on in number 6? We're dividing. So can we divide the numbers? Yes, what's 15 divided by 3? Perfect. And then what happens when you have the same bases and you're dividing? What do you do to the exponents? So it's e to the 3 minus 1. So this becomes what? 5e squared. Perfect. All right, Grayson yes, sir. Sure, cancel out like one of these e's, this becomes a 2. Perfect. Yep, that's the same thing because you're really subtracting. Yep, good. Grayson just asked a good question. He said, if I can just do this in my calculator, here's the thing. Some of the questions are going to say evaluate, which means, hey, tell me the answer. Some are going to say simplify. But then there's some that are going to say like rewrite and. So if it tells you to do something other than just tell me the answer, you have to really show your work. Does that make sense? Like in a case like this, some of you know how to put this in your calculator. Some of you do not. But you are simplifying. It doesn't say tell me the answer or value. It says simplify. So if you were to simplify this, you would rewrite this as log little 7. How can I write 49 with a base of 7? 7 to the what? Squared, and then it's still times the x. You have, since it's telling you to simplify, you have to show that that is your simplification. Why is that simplifying? Well, what happens with log little 7 and a big 7? They cancel, so your answer is 2x. When in doubt, guys, show as much work as possible. I need to see what your brain is doing. All right, how do I do number 7? What do I do with that 3? It goes to the 5, and it goes here, right? When you raise a power to a power, what do you do to the exponents? You multiply. So this is 5 to the 3rd. Thanks, babe. And then I have e to the 12x. Now, you guys will have a calculator, so you don't have to multiply this by hand. If you don't know how to put something in your calculator, today is the day to ask me. I will not answer, how do I do this in my calculator tomorrow? If you don't know how to put that in, just put 5 times 5 times 5. But what is 5 cubed? Good. So it's 125 e to the 12x. All right, simplify. Whenever you guys have one of these simplifies, you are going to be able to rewrite this big number in terms of the little one. So if you need to use your calculator to mess around with the numbers, go ahead. But if I rewrite this as log little 3, what's another way I can write 81 with a big base of 3? To the 4th power. Good. So 4, and then I have negative 2x. Still, that negative 2x is there. So what happens with log 3, 3? Cancels. Negative 8x. Perfect. Questions? This isn't horrible, right? All right, now here is a prime example, guys. They're not asking, you already can see the answer. They're telling you that log 4 of 1024 equals 5. That's not the question is to rewrite it. Sometimes it's going to say to go from this form to this form, and that one not. This one doesn't. You have to make sure you understand. What form are you starting off in? Log. So then you're going to exponential. Good. So what happens when I go from log to exponential? My log crosses off, and my little 4 becomes big. And then what happens with these two? Perfect. Now, guys, the beauty of this, if you have your calculator in front of you, hit 4 to the 5th power. What does it say? 1024. If you rewrite it wrong, you can always go back and check and be like, oh, wait a second, I put the numbers in the wrong spot. All right, what about this one? My base is 1/3. Remember, when we see a fraction, we also think negative exponents. So what happens here? The negative 3 becomes the exponent, and then you have 27. So check that in your calculator. Put your parentheses, put parenthesis 1 divided by 3, close your parenthesis, and then raise it to the negative 3 power. You don't hit the minus sign. There's a little negative on your calculator. There you go. And again, when I'm done here, if you guys have calculator questions, I am happy to help. All right, look at 13. What kind of form are you starting off in? Exponential. That means I need to go to logarithmic. So I'm going to write the word log, and my big 7 becomes little. Guys, make sure you write it little here. This and this are not the same thing. Everybody see the difference there? That's log base 10 of 7. The other one is log base 7. So make sure that is little. And then what happens with 2,401 and 4? They switch spots. So 2401 equals 4. Now some of you are like, well, I want to check it. How do you check that? Do you guys remember your change of base formula? Hit log of what number? 2401 divided by log what? Log 7. It's the log of the visually bigger number divided by log of the visually smaller number. It's the way to check. All right, next one. I'm starting off in exponential or logarithmic? Okay, so I'm going to go to log. So I'm going to write the word log, and my big 4 becomes little, and then I have 0.0625 equals negative 2. Switching from log to exponential is not terribly difficult. You just remember, if you're in log, you cross off log, the little number becomes big. If you're in exponential, you write the word log, the big number becomes little. All right. Next thing says evaluate the logarithm if necessary and round. So I'll use a calculator. Sorry, and round your answer to 3. Okay. What base is this number 15 in? Log base 10. What is your calculator in? Log base 10. For this question, you literally just hit log 45 and round your answer to 3 decimal places. Make sure we round correctly. What'd you guys get? 1.653. Perfect. Okay. Is this still a logarithmic function? Yeah, it's just one of those special ones. It's a natural log. So hit ln in your calculator. Hit ln 1.4. These are like gimme questions tomorrow, guys. Don't get something like this wrong when you just are pressing a button in your calculator. What's ln of 1.4? 0.336. Okay, if you're not getting the same answers as me, that's okay. When we're done here, I'll go over it with you individually. Okay, let's look at 17. Now, there's 2 ways you guys can do this. You can put it in your calculator using the change of base form, which would be what? Log 32 over log 2. Good. Or, how do I tell you guys you think? Do we think logarithmically or do we think exponentially? We think exponentially. If we're going to evaluate this, we want to know what x equals. So think about this. I'm in log. How would I go to exponential? Big 2. And what happens with my x and my 32? So 2 to what power gives me 32? That might be a little easier for you guys to see. If you forget this change of base formula, try to change it into exponential and then look at it. 2 to what power, guys, gives you 32? There you go. Perfect. All right, we're not graphing, so you don't have to worry about that. All right, you are going to have 2 quote-unquote word problems. They're very basic. Think about this. We talked about exponential growth, and we talked about exponential decay. Right? Your growth formula is A, which is your original amount. And if it's a growth, it's a 1 plus or a 1 minus? 1 plus the rate. If it's a decay, it's 1 minus the rate, correct? Okay, easy enough. Now, what do I need to remember about the rate? The rate has to be what? In a decimal. It's always going to be given to you as a percent. You have to change it to a decimal. So in this case, they have everything that we need is right here for us. What is our A value? What did we start with? 150. That's what I paid for my lamp, right? It says the value of the lamp increases. Is that a growth or a decay? A growth, good. What does it increase by? Well, your rate is 2.1%. Is that a decimal? No, it has a decimal in it, but that's not a decimal. How would I change 2.1% to a decimal? Over 2. So this becomes 0.021. If it were a decay, it would be 1 minus. So if you're going to write your formula would be y equals, what's your original amount? 150, right? Times 1 plus 0.21. Is it a 5? What did I write? I forgot the 5, sorry. 215. And then you could simplify that a little more and say y equals 150 times, what's 1 plus 0.215? I forgot to put a 0 here, guys. I'm sorry. I didn't put the 0 here. So it's 1.0215, right? And it's raised to what power? To the t. That's it. So after 5 years, you would put 5 in for t. After 8 years, you would put 8 in for t. It's always in terms of time. But you guys have to recognize the 2 things from this are to recognize if it's a growth or a decay, so if you're going to add or subtract, and then whatever the interest rate is, you have to change it to a decimal. Are we ready? All right, look at the next one. You deposit $1,500 in an account. Okay, this is our interest formula. You guys need to know this. It's P 1 plus. What's my little fraction here in the middle? R over what? N. And we raise it to the N times T. Very good. You guys need to know that. So let's talk about all the parts. What is the P? P is your principal. It's what you start off with, right? What's your R? Is your rate. And how do you need to write it? As a decimal. What is T? Time. Perfect. And then what is this tricky little one, the N? It's how the money is what? Is compounded. They're always going to use the word compounded. They're going to say it's compounded monthly, quarterly, weekly, all that stuff. We went over that on one of the slides. Make sure you guys are familiar with those words. So I have all the information I need. My principal amount. How much am I starting off with? $1,500, okay? What is the interest rate? 7%. So how do I write that as a decimal? 0.07. Good. What is the time that we're talking about? 2 years. Good. And then how is the money compounded? Daily. How many days are in a year? 365. Good. So there's all of the information that we need. If it said weekly, how many weeks are in a year? 52. If it said quarterly, how many quarters are in a year? 4. Okay, you guys got it. So let's plug it in, and then we got to practice in our calculator. So I have 1,500 times 1 plus, you got to put this in parentheses, your rate, which is 0.07, divided by 365. Close that parenthesis. Close that parenthesis. And then when you raise it, you need to put that in parentheses, most of you, in your calculator. So it'd be 365 times 2. Now, if you don't get the same answer that everybody else does, we'll talk about this. It's just a matter of getting your work done. If you look on the answer key, Miss Carver worked it out step by step. You guys are welcome to do that if you want, or you can work it out all together. Just make sure you get the right answer. When you guys put this in your calculator, what do you get? $1,725 and 39 cents. Remember, guys, you should not get an answer that is like ginormous compared to the original amount. If you work it out step by step, you would evaluate this first, then the inside here, then add it to 1, then multiply it by the 1,500. But you should get $1,725.39. If you did it piece by piece versus all at the same time, you may be off a cent or two. That's not a big deal. If the correct answer is 1,725 and you got 2,865,000, problem. All right? Biggest mistake is right here. You guys forget to change this. So if you kept that as a 7 versus 0.07, your number will be very different. Very different. Yes, ma'am.
How many decimal points?
2, because of money. Yes, ma'am. Whenever you're talking about money, like an inch, like a bank, when they give you an interest rate and how the money is compounded. Good question. Whenever they talk about money being compounded a certain way, that'll tell you to use that interest formula. All right, let's move along. Evaluate means to tell me the answer, correct? So some of you know how to put this in your calculator. There's 2 ways that you guys can look at this. You can rewrite this exponentially and say 2 to what power gives me 8, which would be what? X equals what? 3, good. You could also use the change of base as log 8 divided by log 2. Either way, you get the same answer. All right, there's a couple ways you could look at this. Miss Carver looked at it this way. She said, change this to a big 6 and move this like this, correct? What would you have to multiply 6 tons of stuff? How many times? Because you 1 over 36. That's kind of hard to I mean, I know you guys see the relationship. The square root of 36 is 6. You're thinking 1/2, that sort of a thing. Anybody know the answer to this? It is -2. Another way you could look at it is you could rewrite this as log 6. And instead of 1/36, how could you rewrite that as a whole number? If you brought 36 to the numerator, it would be 36 to the what? This is to the first power. So if you brought it up to the numerator, it would become what? -1. Good. So now you could think of it like this. 6 to the x gives me, or actually no, you could go one more step. What's another way I could write the 36 then? 6 what? Squared. So that'd be -2. So then that'll cancel. You can do it that way. There's a bunch of ways you can look at these. Some of you are going to see things differently. Carson.
So, like it's -2 because the inverse of -6 is 1/36.
Yes, because in order for you to get a fraction, you'd have to have a negative exponent. So that's why. All right, look at this one. Again, some of you can put this in your calculator. You'd say log 1 divided by log 5. But if you forget that change of base formula, think exponentially. I'm trying to find out what x equals. So if I think exponentially, my little log crosses out and my little 5 becomes big, right? And then what happens with 1 and x? They switch spots. How is the only way that you could multiply 5 by something and then get a 1? It would be 0. Anything to the 0 power, guys, is what? What's anything to the 0 power? 1. So the x value here would be 1. Just kidding. X is 0. Anything to the 0 power is 1. Sorry. All right, let's do the last thing. I don't want to scare you guys. I'm going to do 3 of these so you know exactly what to expect. Yeah, I want to do 3. I want you guys to pay attention to what we're talking about. You will have a question or two that looks just like this. It's got the lines, it's got the find this, find that, all that good stuff. Let's look at number 1. What does it mean in number 1? What are you doing with the f function and the g function? You're adding, okay? You're just adding them together, combining like terms. The first line wants you to leave your answers in terms of x. All right, the hardest thing for you guys is the domain. So you have to think about what your domain can and can't be. There's sometimes when there's restrictions, guys. If you have an even root in the numerator, do you guys agree that these are over 1? All right, if you have an even root in the numerator, your x value has to be greater than or equal to 0. Why is that? Can you take the even root of a negative number and get a real answer? No. If you have an odd root in the numerator, let's think about this. Can you take the cube root or the fifth root, or can you take the odd root of a positive number? Yes. Can you take the even root or the odd root, of a negative number? Yes. Can you take the odd root of 0? Yes. So are there any restrictions? No. When you're in the numerator, you're good. When is there a restriction with an odd root? When it's where? In the denominator, because your denominator can't be what? 0. Other than that, you're good. If there's no roots, you don't even have to worry about it. So let's talk about this for a second. You are adding these two together. You don't have a denominator, so you have to worry about it. So what's the problem? What's your domain? What are the values that you're allowed to use? Anything what? Greater than or equal to 0. Can it be 0? Yes. What's the fourth root of 0? What times itself 4 times gives you 0? 0. Right? So this question is asking you, we'll call this number 1 here. It's asking you to add. So you have -5, fourth root of x, plus 19, fourth root of x. Can you add these two together? Yes, they both have like terms, correct? What's a -5 and a positive 19? So this is 14, fourth root of x. That is your answer. God bless you for right here. This is 14 times the 4th root of x. Notice how the 4 is little, right? You're just asking you to combine. Now, the last question is saying, okay, let's go ahead and evaluate when x is 16. So you have 14 times the 4th root of 16. What do you do first? What do you evaluate first? Right, the root. What is the 4th root of 16? What number times itself 4 times gives me 16? 2. So then 14 times 2 is 28. Perfect. All right, let's go down. Let's go to this one, number 2. We'll call this 2b. What are we doing in this case? What does that say? F what? Divided by G. Okay, when you guys have division, what do you have to think of? What do you have to remember? What do you have to be careful of when you have division? Tell me. What can the denominator not be? Denominator can be negative. What can it not be, Jeremiah? Can't be 0. Your denominator cannot be 0 of a fraction because when it is, then it becomes undefined. So in this case, let's look at what we have here. I have f is 2x cubed, and g is the cube root of x. Do you have any domain restrictions here? Do you have any numbers you're not allowed to plug in? Can you multiply a negative number by itself 3 times? Yes. Can you multiply a positive number by itself 3 times? Yes. There's no domain restrictions there. Do you have a domain restriction here? Can you take the cube root of a negative number?
Yep.
Yep. Can you take the cube root of a positive number? Yep. All right, so there's no domain restrictions in either of these independently. But the problem is when you put one on top of the other, what could possibly happen here? What happens if I plug in 0? It won't work. Why won't it work? Because then your denominator becomes 0. So what's the only number in the world you're not allowed to use?
0.
So you can say, I can use all real numbers. If you want to write the word all real numbers, that's fine. Except what? Perfect. You can use anything negative. You can take the cube root of negative numbers. You can do anything positive. Now, when it says to simplify, guys, that is not simplified. We can rewrite this to where our exponents can be simplified. This is 2x to the third. What's another way I could write the cube root of x as a fractional exponent? X to the what? To the 1 over 3. Perfect. Do I now have same bases and we are dividing? So that means what do I do to the exponents? I subtract them, right? So 3 over 1 minus 1/3. Well, what's 3 over 1 become? 9 over 3. I have to have a common denominator, right? If I have 3 over 1 minus 1 over 3, what's my common denominator between those two? 3. If I multiply the bottom by 3 and then the top, so this becomes what? 2x to the 8/3. Perfect. That is simplified. That is in terms of x. You have 2x to the 8/3. Now it says to evaluate with negative 27. Let's watch how this works, guys. You have 2x to the 8/3. Instead of x, I'm going to plug in what number? Negative 27. Okay. To the 8 over 3. Whoa, what's another way to write that? Perfect, Jeremiah. This is 2 times the cube root of negative 27 to what? The 8th power. Everybody with me? So now I say, okay, well, I have 2. What is the cube root of negative 27? What times itself 3 times gives me negative 27?
3.
So negative 3 to the 8th power. Now you guys have a calculator. In your calculator, you have to do exponents first. You need to have this in parentheses. Your negative 3 needs to be in a parenthesis. So hit 2, parenthesis, negative 3, close your parenthesis, raise it to the 8th power. 13,122. Exactly. 13,122. Now, if this were a multiple choice question, you guys need to understand that this and this are the same thing, right? If they stop one step before, you need to be able to see that. Say it one more time. If it's multiple choice, they won't have both of those answers. I'm just saying, like, if they didn't simplify it, they just left it as the one that I boxed out, then that's fine. All right, I'm gonna do one more, and then we'll stop talking. Wait, did I cut it off? What about if we do, we'll look at it. We'll look at it. Let's do this one, F divided by G. All right, this is the same kind of thing. Let's talk about domain for a second. All right, if I have my F function is 4 x to the 4th, do I have any restrictions there? No, I can raise any negative number to the 4th power. I can raise any positive number to the 4th power. It's fine. Then I have g to the x is 3 times the square root of x. That's not cube root. Do I have a domain restriction there? What's the square root of negative 4? What kind of 2? Guys, what's the square root of negative 4? Put it in your calculator right now. Do square root negative 4. It's imaginary. Can you take the square root or an even root of a negative number and get a real answer? No, so there's a domain restriction here. What can you only use? Numbers that are what? Greater than or equal to 0. Okay, so now let's think about that. We know there's a domain restriction. What are they asking us to do here? To divide. So I have 4x to the 4th over 3 times the square root of x. Now, does my domain change? A little bit. What happens if I plug in 0? It won't work. It becomes 0, right? So what is your domain here? Just greater than. Remember, if something is in the denominator, if you have a radical in the numerator, it's greater than or equal to. If you have an even radical in the denominator, it's just greater than. You guys have got to remember that. In the numerator, an even radical can be greater than or equal to. In the denominator, it only is greater than. So now the rest of this is easy. If we're going to simplify this, this is 4x to the 4th. What's another way I can write the square root of x as a fractional exponent? X to the 1/2, okay? So now I am dividing bases that are the same. So I have 4x to the 4th minus 1/2, and my 3 stays down there. It doesn't go anywhere. So now I have 4 over 1 minus 1/2. I have to get a common what? So this becomes a 2. If I multiply the top by 2, this becomes an 8. Agreed? Yes or no? Okay. So I have 4x to the 7/2 over 3. That is simplified. That's all you need to do there. You have 4x to the 7/2 over 3. And now you're going to evaluate using what number? We're going to plug in using 4. So I have 4x to the 7/2 over 3. And I'm going to plug in 4. So I have 4, use a different color, 4 times 4 to the 7/2 over 3. That's another way I can write 7/2. The square root of 4 to the 7th power, good, over 3. Guys, what's the square root of 4? So I have 4 times 2 to the 7th over 3. Use your calculator. Say it one more time. 512. Is that what you're saying, Jeremiah? 512 over 3? Okay. Simplify the numerator first. What's the square root of 4? 2. 2 to the 7th power is whatever, times 4, divided by 3. If it says no decimals, which it probably will, you need to leave it as a fraction, just like Jeremiah did. But your biggest thing, guys, the biggest takeaway you have to remember, even root in numerator. I already wrote this down, but we'll do it again. Your domain is x has to be greater than or equal to 0. Even root where? In the denominator, what's your domain? X has to be what? Greater than 0. Why does it have to be greater than? Not greater than or equal to? Because the denominator can't be 0. Good. If you have an odd root in denominator, odd root doesn't matter. If it's in the numerator, you can do whatever. But odd root in denominator, x cannot be 0. Because if it is, then your denominator is 0. So as soon as you see an even root, you need to think, ooh, okay, is it in a numerator? Greater than or equal to 0. If it's in a denominator, it's got to be greater than. Everybody okay? All right, I will upload this right now. And if you have